Hello, this is Chase Ayers. This is my Creative Assignment 3 lecture on material failure in mechanical engineering, as well as understanding how and why materials fail. So, the overview for this lecture, what I'll be showcasing today, is what is material failure and why it matters in mechanical design, types of failure within mechanical design, failure prediction and prevention methods, as well as real-world mechanical engineering applications. So getting started off, what is a material failure? This occurs when a material can no longer withstand the applied stresses on it, and this can lead to permanent deformation or eventual fracture. This can also be sudden for brittle materials or gradual over time for ductile materials. So the equation for applied stress on an object is force divided by area, and the stress concentration can cause failure on an object when the local stress is greater than the yield or ultimate strength. And two examples of failure is necking and fracture. Some other specific examples of material failure is ductile failure, brittle failure, fatigue failure, and creep failure. So starting off with ductile failure, this happens when it is a large deformation before a fracture, and this happens commonly in steel shafts. Brittle failure is little deformation before a sudden break, and this can happen in iron gears. Fatigue failure is repeated cyclic loading on an object, and this happens very commonly in cars with crankshafts. And the creep failure is a time-dependent deformation over a period, and this can happen in fan blades at high tension for a number of applications as well. So here is the stress and strain curve and failure regions of a graph. The elastic region is where the material can return to shape. When it exceeds that region, it becomes a plastic region, where this is permanent deformation. And then after that, if you fall along the curve, the fracture point is the ultimate failure. So the equation for the elastic region is E times epsilon. Here, in this region, this is the elastic limit. And then after it's that, it's going to continue to the plastic region, where it reaches the ultimate strength as well as the ending fracture point. So fatigue failure, with a key focus in mechanical engineering, it happens most commonly in parts that fail in machines that we design. And it also happens when a material is loaded repeatedly, even if the stress is below the yield strength. And over time, tiny cracks form within these parts and grow until the part eventually breaks. And this is shown here to the right by the SN curve, which relates stress to the number of cycles to failure. So the maximum stress will decrease as the cycles continue to get higher until it eventually flattens out and the part breaks. So here is some specific examples of mechanical systems failing. In the automotive field, the axle or crankshaft fatigue, as you can see to the left here, is a good example of a crankshaft failure. In robotics, things can fail due to repeated loading of arm joints. And then lastly, in manufacturing, things can fail in press dies or cutting tools as well. So for predicting and preventing failure, we will use the factor of safety N, which is the sigma yield over the sigma working, or the stress yield over the stress working. And this can help us determine the material selection, being the toughness and ductility, as well as the surface finishing and heat treatments that we allow the material to go through. and we will also be making regular inspection and NDTs to help prevent failure of parts as well. So connecting this back to mechanical engineering, we want to design safe, efficient, and reliable machines. We can also use this information to understand failure and help prevent costly breakdowns of the things that we design as well as essential in the automotive, aerospace, as well as energy systems fields that many mechanical engineers work in. And this idea of failure is also applied in courses like machine design, dynamics, and mostly material science as well. And this is the design flowchart when creating a new product, and failure definitely plays a role when creating a new product as well. So in summary, the key points that we went through in this lecture is failure, which is the loss of material integrity under stress, the types of stress being ductile, brittle, fatigue, and creep failures, as well as why, as engineers, we must predict and prevent failure using theory and testing, and understanding that failure can help us realize safer and more durable mechanical systems as well. Here are the references for the images that I used. Thank you.